Hello everyone. In this video, we are going to learn RSA algorithm from the subject Cryptography and Network Security. We will see how RSA algorithm work and also some examples that are important for your examinations. So, one of the first successful responses of the challenges was developed in 1977 by Ron Rivest, Adi Samir, and Len Edelman at MIT, and the first published in 1978. So the full form of RSA will be given from these three scientists, that is first one is Rivest, Samir and Edelman. Okay. So in RSA, actually the plain text is a integer number that you have to keep in your mind. RSA algorithm में हमारा जो भी plain text होगा वो characters नहीं होंगे, for example hello world and all. Okay, that must be an integer. Why this RSA algorithm takes that particular message in integer? Because the plain text first it is converted into an array of bytes. Whatever your message, actual message is, that will be converted into an array of bytes. Then bytes are converted into a large integers, and that integer will be encrypted with the help of RSA algorithm. So अभी तक हमने जो भी algorithms देखे, you can take Playfair cipher, you can take Hill cipher, Caesar cipher, वो सब में क्या था, जो भी plain text हम use करते थे वो text form में था, for example hello world and all. Okay, but in RSA algorithm the plain text first, the text will be converted into array of bytes, then that bytes are converted into integer. So आपको इस algorithm में जो भी message मिलेगा वो कौन से form में होगा, integer form में, ये आपको याद रखना है. Okay, so RSA is a block cipher in which the plain text and cipher text are represented as integer between 0 and n-1 for some n. So as I say, large message can be broken up into a number of blocks. So each block would then be represented by an integer. Okay. So what is the step 1 for RSA algorithm? First we have to generate a public key. It consists of E, N. What is E, what is N? I will explain you in algorithm or when we are doing the numerical of this RSA algorithm. Okay. And the private keys of the pair D, N. So in RSA algorithm, it is mandatory to encrypt the message with the help of public key of the receiver, and the receiver will decrypt the message using their private key. So this is also important because in elegable digital signature the encryption will be done with the help of the private key and decryption will be done with the help of public key. So it's a public key crypto system, that is asymmetric key cryptography. So one key is used for encryption, then second key will be used for decryption. So in RSA algorithm आपको ये याद रखना है, पब्लिक की से ही हम मैसेज को एनक्रिप्ट करेंगे और जो भी डिक्रिप्शन होगा रिसीवर साइड से वो कैसे होगा, वो रिसीवर की प्राइवेट की से होगा. Is that clear? So first we will see how public key will be generated, because to generate this n it is easier, but to generate this E and D, that is somewhat difficult. Okay. So now let us see the step number 1, how we are going to generate public key and private key. So we have to select two large prime number P and Q. For simplicity, for solving an example, we are selecting to not a very large prime number. We can select a small prime number. Okay. Then calculate modulus, that is n. How it will be calculated? P into Q. Suppose P की value 7 है, Q की value 11 है, तो 7 into 11 is 77 will be the value of n. Next, calculate Euler-Tocsin function. How it will be calculated? Tocsin function of n is equal to P minus 1 into Q minus 1. Suppose the value of P is 7 and the value of Q is 11, then 6 into 10 will be the answer of Tocsin function of n, that is 60. Okay. Next, select E such that A is relatively prime to Tocsin function of n and E must be greater than 1 and less than Tocsin function of n. So this E you have to select, but it must be relatively prime to Tocsin function of n. Now this is important, how to check that the particular value is relatively prime to another value. Suppose suppose the value of p is 3 and the value of q is 7, then what is our n? 7 3 is 21. Then what is tOSN function of n? So 3 minus 1, that is 2 into 6. 6 2s are 12. 12 is the value of tOSN function of n. Okay, so we can select E less than greater than 1 and less than 12. Okay, so we can select 2, 3, 4, 5, 6, 7, 8, 9 and 10. But we have to check that particular E will be relatively prime to tOSN function of n. Okay, so what is our value of tOSN function of n? If we are taking p equal to 3 and q equal to 7, then tOSN function of n is equal to 12. So if you select 2, then the common factor, how we can check the E is relatively prime to tOSN function of n or not? The common factor of 2 and 12 is 2 actually. Okay, so if I select 3, so the common factor of 3 and 12 is 3. If I select 4, the common factor of 4 and 12 is obviously 4, because we can divide 12 by 4 into 3. Now if I select E is equal to 5 and our tOSN function is 12, then the common factor is 1. When I can say E is relatively prime to n, so 5 is relatively prime to 12 because the common factor of, suppose the factors of 1 and 5 is, first one is 1 and second one is 5. Okay, and the common factor of 12 is 2 6 are 12, then 1 12s are 12. Next common factor is 3 4s are, then 4 3s are, and 6 2s are 12, and last one is 12 1s are 12. Okay, so you can see the common factor of 5 and 12 is only 1. Then and only then we can say the 5 is relatively prime to 12. So the simple definition, these two numbers are relatively prime if they have no common factors other than 1. Let us see with the help of example. So suppose this is the value of E on the left hand side, and suppose the value of tOSN function of E is there in the right hand side. Okay, so I can say 5 is relatively prime to 8. How? What is the factor of 5? 1 and 5. 1 5s are 5, 5 1s are 5. Next, what is the factors of 8? 1 8s are 8, 2 4s are 8, 4 2s are 8, and 8 1s are 8. Here you can see the common factor is only 1. Okay, there are no common factor other than 1. That's why I can say 5 is relatively prime to 8. It is very simple. Okay, so we have to select 8, but it is less than tOSN function of n. Sorry, we have to select E, it is less than tOSN function of n and greater than 1. So 1 we are not able to select. So we in examination you may confuse what is the value of E. So this way you have to find the value of E. Here is a second example. 7 is also relatively prime to 10 because the factor of 7 is 1 and 7. Okay, and the factor of 10 is 1, 2, 5 and 10. Here also the common factor is 1. So I can say 7 is relatively prime to 10. Okay, similarly for 9 and 28. So I hope you understand what is relatively prime number. Okay, now next, determine D such that D is equal to 1 plus j into tOSN function of n. Okay, by computing these this 4 step, in the third step onwards we are able to get the value of tOSN function of n, and also in the previous step we will we get the value of E. Okay, but what about j? J will start from 0 1 2 3 4. कब तक हम उसको अपडेट करते रहेंगे j की वैल्यू को, जब तक ये एक्सप्रेशन का रिजल्ट इंटीजर में नहीं आ जाता. So determine D such that D is equal to 1 plus j into tOSN function of n divide by E. The result of this expression must be in integer, then that particular integer value will be the answer of D. Okay, ये आपको मैं नेक्स्ट स्लाइड में एक्सप्लेन करता हूँ. स्टेप नंबर 1 विद द हेल्प ऑफ टेकिंग द वैल्यू ऑफ P and Q. Okay, how we are finding this D, I will explain you in the just next slide. Okay, so after determining E and D, N is already there. So our public key is the pair of E and N, as I said earlier, and our private key is D and N. Okay, D we will get from here, E we will get from here, that is relative to prime to tocen function of N, and tocen this N will be calculated from here. So if we have, once we have a public key and private key, we will encrypt the message with the help of public key and decrypt the message with the help of private key. Okay, so this whole step number 1, I will once again continue with the help of the values of P and Q. Just see. Suppose the value of P is 3 and the value of Q is 11, then what is our N? N is equal to P into Q, that is 3 into 11, that is 33. Okay, now what is tocen function of N? Tocen function of N is equal to P minus 1 into Q minus 1, that is 3 minus 1 into 10 minus 1, that is 20. Okay, now we have to select E. Now what is the criteria for selecting E? E must be greater than 1 and less than tocen function of N, and it must be relatively prime to tocen function of N. Okay, so if I select 2, the common factor is 2, not 1, between 2 and 20. If I select 3, it may be a yes, the common factor is 1, because the factors of 20 is 1, 2, 4, 5, 10 and 20. Okay, and the common factors of 3 is 1 and 3, so the common factor is 1. So we can select E is equal to 3, we can select E is equal to 7. Okay, so आप ये सोच रहे होंगे सर आपने क्यों 7 लिया, 3 आपने तो बोला 3 भी चलेगा, but I can take 7 ना, because 7 is fulfilling this criteria. 7 is greater than 1 and 7 is less than tocen function of N. I can take 3, it is also 2. Okay, so the factor of 7 is 1 and 7, and the factor of 20 is 1, 2, 4, 5, 10 and 20. So you can see the common factor is only 1, that's why we can take E is equal to 7. फिर से कह रहा हूँ, you can take 3, 5 नहीं ले सकते because 5 is a factor of 20. Okay, so 5 हमारा क्या हो जाएगा, कॉमन फैक्टर हो जाएगा, हमें कॉमन फैक्टर सिर्फ 1 चाहिए. क्लियर है? Okay, now determine D such that actually the formula is D into E mod tocen function of N is equal to 1, but we can rewrite this as D is equal to 1 plus J into tocen function of N divided by E. It must be an integer, that is the value of D. Okay, we already have tocen function of N, we already have E, the value of J will be started from 0. Suppose J is equal to 0, then what is D? D is equal to 1 plus 0 into 20. So 1 plus 0 into 20 is equal to 1, divided by 7. So 1 divided by 7 is 0.14. It is not an integer. So this is not an answer of D. Okay. Now we increment J equal to 1. If I increment J equal to 1, then what is the value of D? D is equal to 1 plus 1 into 20 divided by 7. So 20 plus 1 is 21. 21 divided by 7 is 3. So what? This is an integer. This is not in the decimal value, or we can say not in the fractional. Okay, it's an integer. So this is the value of D. I think अब आपको बहुत प्रॉब्लम समझ आ गया हो. आप बोलोगे सर J इक्वल टू कब तक हम जाएं? जब तक आपको इंटीजर वैल्यू नहीं मिल जाता है तब तक आपको J को इंक्रीमेंट करते जाना है. You have to calculate, and if you get the integer value, then that is the value of D. Okay. Okay. So what is our public key? Public key is equal to E and N. What is our E? 7. What is N? 33. And what is our private key? D and N. So 3 and 33. So RSA algorithm में सिर्फ E is very simple to calculate. और ये D की फॉर्मूला अगर आपको याद होगी तो एग्जाम में आप इजीली कोई भी मैसेज को एनक्रिप्ट कर सकते हो, डिक्रिप्ट कर सकते हो, बिकॉज एनक्रिप्शन एंड डिक्रिप्शन प्रोसीजर इज इजियर. ओके, सिर्फ बड़े वैल्यूज का आपको मोड फाइंड आउट करने को आना चाहिए. दैट्स इट. ओके, लेट्स सी स्टेप नंबर 2, how to encrypt the message with the help of RSA algorithm and how to decrypt the message. Okay, so for encrypting the message, what is the formula? Simple formula for if we are encrypt any message, we get the ciphertext. Okay, so C is equal to m raised to e mod n. What is m? M is a message. In most of the paper message is given. Most of the paper में message दिया होता है like m equal to 14, m equal to 10, m equal to 6. अगर नहीं दिया है तो आपको सिलेक्ट कर लेना है, बट वो इंटीजर वैल्यू होना चाहिए, नॉट इन एनी सेंटेंस और नॉट एनी कैरेक्टर्स. इज दैट क्लियर? ओके, नाउ वी ऑलरेडी हैव e, वी ऑलरेडी हैव n. सपोज okay, so m is an input message, is e and n is our public key. Suppose m is equal to 14. In RSA algorithm, I already told you that encryption will be done with the help of public key. You can see 7 and 33. With the help of 7 and 33, we will encrypt the message. Suppose m is equal to 14, then c is equal to 14 raised to 7 mod 33. 14 raised to 7 mod 33. Okay, you have to calculate in the calculator. Exam में please calculator लेके चलना, otherwise you are not able to find the biggest number mod 33. Now 14 raised to 7 अगर आप कैलकुलेटर में करोगे तो बहुत लार्ज नंबर आ जाएगा, यू आर नॉट एबल टू फाइंड द मोड. सो हमने क्या किया, 14 raised to 1 mod 33, 14 raised to 2 mod 33, 14 raised to 4 mod 33 किया. दैट मीन्स 4 plus 2 6, 6 plus 1 7, तो 14 raised to 7 हो गया. Now what is the answer of 14 mod 33 is 14. Okay, now 14 raised to 2 मतलब 14 square mod 33, the answer is 31, and 14 raised to 4 mod 33, the answer is 4. If you get the answer of this 3 sub expression, then you have to once again multiply this number 14 into 31 into 4 mod 33 करोगे तो आंसर आएगा 1736 mod 33. So what is the answer of 1736 mod 33? Answer is 20. अब बोलोगे सर मुझे इतना बड़ा एक्सप्रेशन नहीं करना है, मैं उसको 3 और 4 में डिवाइड करना चाहता हूं, तो यू कैन लाइक 14 raised to 3 mod 33 into 14 raised to 4 mod 33. जो भी आंसर ये दोनों का आएगा आप उसे फिर से मल्टीप्लाई करके mod 33 करो तो योर आंसर विल बी 20 ओनली. इज इट क्लियर? ओके, so what is our ciphertext? Ciphertext is 20. Now if I decrypt this message with the help of this ciphertext 20, once again I will get the original message, that is 14. How? Let's see in step number 3. Decrypt message. For decrypting the message, we get the original message. That's why we have to write m is equal to c raised to d mod n. So d and n is a private key of receiver. Okay, so what is our d? We already have d is equal to 3 and n is equal to 33. So the value of c is already we get, that is 20. So for getting the original message, that is m equal to 20 raised to 3 mod 33. Okay, if you calculate 20 raised to 3 mod 33, the answer is 14. Is that clear? This 20 raised to 3 mod 33 will directly calculated by the calculator also. You can calculate directly, you will get the answer 14. So this is how this whole algorithm works. Okay, first we have to create public key, private key. If it is given, then it's okay. Then you only have to remember the formulas. For ciphertext, c is equal to m raised to e mod n. For getting our original plain text, m is equal to c raised to d mod n. Okay, let's see one another example. So you have some grip on this topic. Okay, what is the question? Find n, Rosen function of n, e, d for a prime number p is equal to 7 and a prime number q equal to 90. Then demonstrate the encryption and decryption for the message m equal to 6. अब ये हर पेपर में नहीं दिया गया हो. फॉर एग्जाम्पल आपको ऐसा कह दिया गया, एक्सप्लेन आरएसए एल्गोरिथम विद द हेल्प ऑफ एग्जाम्पल, तब आप क्या करोगे? ओके, तब आपको टू प्राइम नंबर्स लेने हैं P and Q, मैसेज भी खुद से लेना है, E खुद से कैलकुलेट करना है, D भी खुद से कैलकुलेट करना है. Okay, now first what we calculate? N, that is modulo N is equal to P into Q, that is 7 into 19, the answer is 133. Next we will calculate tossan function of N. Now tossan function of N is equal to P minus 1 into Q minus 1. Okay, that is 6 into 18, that is 108. Now what we do, we have to select E such that it is greater than 1 and less than 108. So from 2 to 107 any number will be there, but which is relatively prime to 108. Okay, so फाइंडिंग रिलेटिव प्राइम. चलो हम रिलेटिव प्राइम चेक कर लेते हैं. पहले 2 और 108 का कॉमन फैक्टर फाइंड आउट करेंगे और वी कैन से जीसीडी फाइंड आउट करेंगे. 2 और 108 का जीसीडी क्या आ रहा है? 2. द कॉमन फैक्टर इज 2, 1 and 2. सो वी कैन नॉट सिलेक्ट 2. नेक्स्ट 3 अगर सिलेक्ट वैल्यू रखते हैं E की, तो E और 108 की कॉमन फैक्टर क्या आ रही है? 3. ओके, नाउ सिलेक्ट 4. If you doesn't get the answer by selecting 2, you are not able to gain the answer by E equal to 4. Okay, now if I select E is equal to 5, and if I find the GCD, or we can say the common factor of 5 and 108, that must be 1. Okay, 108 will not divide by 5, you can check. Okay, so we will select E is equal to 5 because 5 is a relatively prime to 108. And it is less than 108 and greater than 1. So what is our E? E is equal to 5. Now we have to find D such that D is equal to 1 plus J into tossan function of N divided by E must be integer, as I earlier said. So by putting J equal to 0, first we check. If I put J equal to 0, then D is equal to 1 plus 0 into 108 is 0. So 1 divided by 5 is 0.2. It's not an integer. Now if I select J equal to 1, then it will be 109 divided by 5, that is 21.8, also not an integer. If I select J is equal to 2, then I get 217 divided by 5, it's also not an integer. Now if I select J equal to 3, then 325 divided by 5, that is 65, that's an integer. So the value of D is 65. So we calculate E, we calculate D. So we get the private key also and public key also. So we will encrypt the message with the help of private key. Let's how see. So for encryption, what is the formula? C is equal to m raised to E mod n. What is our m? 6. Okay. Now 6 raised to 5 mod 133. The answer is 62. Now if I decrypt this message, so for decrypting the message, what is the formula? M is equal to C raised to D mod n. Okay. M is equal to C raised to D mod n. What is our private key? 65 and 133. So 62 raised to 65 mod 133. Now in calculator, 62 raised to 65 is impossible. So you have to break this 62 raised to 65 in 5, like 62 raised to 5, 62 raised to 5. How many times we have to do? 11 times. Okay, not 11 times, 13 times I think. 13 into 5, that is 65. Okay, so then you will get the answer 6. Also, if your whole answer is correct, if you directly write 62 raised to 65 mod 133, obviously what is your answer? Answer will be 6, because you are given that m is equal to 6. So after decrypting the message, the answer will be 6. You can directly, you can also write directly. आप directly लिख दोगे तो भी कोई marks cut नहीं करेगा. But बड़े number का mode आपको find out करना आना चाहिए. I am not able to see the calculation right now, but I will explain you. You can check the videos on YouTube that how to calculate big numbers modulo number. You will get some of the link. Okay, so this is how we can calculate with the help of RSA algorithm. So in examination, please keep in mind the message must be in integer. Don't take any string or any sentence to encrypt the message. Okay. So these are the questions that is already asked in examination. The first question is in public system using RSA, the ciphertext intercepted C equal to 10, which is sent to the user whose public key is equal to 5 and equal to 35. Now what is the plain text? You have to find the plain text. Okay. Second, third, fourth, fifth, all the questions are asked in 7 and 4. So prepare well, and if you have any query in solving this any of the problem, then contact me. Thank you.